This is Building Query, July 17, 2020. We had a little bit of an informal agenda, which may have changed in the last few minutes. I don't know how ready you are, or, oh, you are?
Ready.
Oh, okay, great. So I don't know if B5, you want to run through a little agenda. We can welcome Z, say hello. We can introduce some new team members who might not be familiar with since the last time we all saw him. But...
Absolutely. I think today we've got two things we want to talk about. Some work we've been doing. This is the end of sprint N for us. And so we've got a bunch of stuff that we've come up with. We talked a little bit on the last call about Query Cloud improvements that we shipped. But today I think we want to focus on a bit of a work in progress, which is our Query Python client, and specifically how we're going to work on it inside of Jupyter Notebook. And then for the actual dev building oriented discussion, I'd like to have a bit of a conversation about our APIs and the numerous ways that a number of things are now interacting with Qri Core. Qri Core is the sort of Golang implementation, the only real implementation of Query. And just understanding, let's start doing some thinking around plotting of the future of that and any extensibility, and basically try and get some agreement going on where we should be taking our different API implementations. And by looking at both clients and what gets put out. So with that, I think Chris has prepped the actual Python demo. Is that true, Chris? Cool.
That's true.
I think from there, if you want to take it over, good start.
All right, here we go. Let me find the correct window to share. Okay, can you see my my browser? All right, so we have a empty, clean slate Jupyter Notebook. Right now, there's a Python client that we've developed. It's not quite published yet, so what you aren't seeing here is that behind the scenes, I have a symlink to the development environment or the development directory that has that code in it. But once it's ready, it would be basically pip install Qri Python, I believe is what it's called. But we can start with just doing an import here, and it'll just use the symlink behind the scenes. If we run import query, we now have the ability to do things like query list. So this is the same as typing query list. Query.list in Python is the same as typing query list in command line, and we should get a nice little list of data sets that are currently in the repo. We had a little technical glitch trying to pull down data from cloud earlier. So with this demo, I'm just going to use a data set that I already have locally, which is the most famous data set of all, World Bank population, which is just a bunch of population figures for the world published by the World Bank. So what we can do, actually, first I'm going to import pandas, because I didn't do that. Let's put pandas up here. And let's run that. Okay. So what we can do is I can say data set. Actually, let's give it a better name. Let's just say World Bank population equals query.get, and then we'll just type in the dataset reference, which is B5/World Bank population. Okay, so this will set up. So it didn't log anything because we didn't write it down, but or we didn't choose to log, but we can actually say things like wbp.body, and that'll give us the dataset body. So I'm going to go ahead and just assign that to a data frame variable. So just call it df, which is a convention people like to use in Python, or in pandas anyway. So let's hit run on that. And again, didn't log it, so let's just log it again by running df. So there's our body. So we can explore this and see 65 columns, 214 rows. So if I didn't have this locally, with another command in here, we would have been able to pull that down from Query Cloud, which is wonderful, and just be, have it ready to be worked with in Python or in Pandas as a data frame in just a couple of commands. No downloading CSVs, no putting them in the right directory. No, having to figure out how to get them imported properly and name their columns and things like that. That would have just worked. So now we've got the data frame in, and we're ready to do some basic stuff on it. So let's say I want to just do get the top 15. Get the top 15 by population. And I'm going to do that by year 2018. So if you look over here in the column, we've got year _ 2018, which is the last complete year of data. So I'm going to do that by saying new data frame called top 15. We're going to say df.sort, sort underscore values. And then we tell sort values by equals the column name. So let's do year 2018. And we're going to say ascending equals false with a capital F because it's Python. And I'm going to then take the head of that for only the first 15 rows. And then let's log it by saying top 15. And now we've got 15 rows by 65 columns. And here's the year that we're interested in. So we can make a simple chart out of this. So I'm going to use plotly.express for that. So let's import that. And what we can do here is just say fig equals, and then this will say plotlyexpress.bar. We'll use top 15, which is the name of our truncated data frame that's just got the top 15 in it. We'll do x equals country underscore name, and we'll say y equals the column name we want, which is year underscore 2018. And if we just say fig.show, we should get a nice little bar chart. There it goes. Okay, so we can see India and China, as we would expect, are in the lead, followed by United States, Indonesia, and things that made the top 15 that I wasn't expecting are Vietnam, Egypt, Philippines, etc. But we get a nice sense of the curve and where the leaders are. And we can also do some nice things like fig.update. Let's add a little title to this, and then we'll finish the demo. Update underscore layout. Let's see. And then we'll say title equals top 15 countries by total population 2018. And let's run that again, and we'll have a nice title on our chart. And there you have it. So other things we could do, actually, let me see if I can get that to work. If we have, so remember our data frame, sorry, our data set, not our data frame, but the data set was called WBP. So down here I can say, get the meta, get the query meta, and I can say wbp.meta. Let's see if that works. Oh, didn't work. Let's do meta.title. There it is. And we can say wbp.meta.description. And let's see what that gets us. There it is. So we can just call, any part of the meta or any of the other components that are built into query. So we're also going to be looking into a thing called preview, where we can just say query.preview, and it'll give us effectively the same information that's on query.cloud on a dataset page. Enough to get familiar with the dataset, understand its schema, see the first X number of rows, probably 50 or so, and then also check out the metadata. We can also do some interesting things with formatting this, because in Jupyter Notebooks we can do HTML content and things like that, just like Plotly's doing with these charts. So the sky's the limit in terms of things, and we'd love to hear your ideas for what would be good and useful if you're a Python person that uses pandas. So I think that's my demo for now.
Woo! Delightful. It's great. Chris, do you mind stopping screen share, and we can maybe, oh, I love the piece of clap emojis. I haven't heard the clap, Zoom clap feature, whatever this is. Anybody have any questions on that?
That's super cool. That's the first time I've seen that in action, and I think it's super exciting. I have questions about like where we're trying to go from, like what the goals are for the Query Python client. Are we also trying to save, add saving features and any of the other stuff that I know that we can do with Query that may or may not make sense to pull into Jupyter? So just curious.
I think save is definitely on the to-do list. It's one of the things that we want to add next. It was in the older version, but has to be updated to work now. But yeah, that's definitely on the way. It's unclear if it'll become like a full replacement for the command line, but we definitely want to enable, I guess, kind of the most popular workflows that you would see in a Jupyter Notebook. That's the way I'm thinking about it.
Publish or push? What are we thinking?
Good question. I don't know. That
I would think
that's
so.
I think so.
Yeah. No, I mean, I think it's a pretty reasonable, feasible user story to get someone else's data set, filter it down to the stuff I care about or my team cares about, and then push it right back up as a separate thing. So that can be done in a few lines of code, and I don't have to, have Query Desktop and move files around or anything like that. I could just run some Python and then just fire it back up push it back up to cloud.
Mm-hmm. Yeah, deep agree. I think the other ones, a couple of, like, as Chris mentioned, when we actually can show the demo of add, where you can just like literally pull something down and immediately start working with it, that'll be a biggie. The other one I'm excited about is SQL. So you can literally just have query calculate some SQL for you, return a data set that is the result of that SQL execution on the query side. That SQL could include joining multiple data sets, right? So you could actually bake up a query that pulls together an SQL query that pulls together numerous data sets, have those be automatically fetched in the background because 099 now automatically fetches in the background, produce the results, and then generate that as a data frame, save that, and then have that, like, do additional EDA on it, save that, and publish that. I think the much harder of the two is actually saving, because you have to figure out the API for providing lots of arguments the way that, and I think it actually works better in Python than it does on the command line, where we have, like, the way we kind of do it in the command line is we create numerous files that can constitute components of the data set. So we can make a file that's like the meta.json often, or you can make one big dataset.json file. But I think it's actually much easier to just do that all in a data frame environment. This is a nice side of things. Where this actually, I think, makes a wonderful transition into the conversation about APIs. So before we go there, anybody have any other questions on the Python demo?
I just wanted to ask, like, is there going to be a cloud first version of this in terms of like having a hosted Jupyter thingy, not have to set up my own?
I think that's the question of the hour, right? Because we have a number of folks who are using different hosted Jupyter environments where we would have to operate entirely, where Qri Core would have to be operating entirely over an API in a way that is backed entirely by an API, even if, and then that begs the question of, and I think that's the purpose of today's discussion is, okay, we have this great demo. And so, okay, officially transitioning over to the API discussion. And so I'm gonna just share a screen really quickly on like kind of our state of the world, and hopefully that'll help us sort of get to that, get to this conversation about like, what do we even mean when we talk about an API, and like, how do we, and make sure we're sort of plotting the right path forward for that. My sleight of hand like attempts to talk through my screen share figure out discussion didn't go as smoothly as expected, but so today I just like quickly prepped like the world's simplest and smallest chart of our actually somewhat complex thing. And so Asmer, your question was like, what about online, Jupyter Notebooks online, or a notebook in a hosted environment? And I think before we get to, I think the ultimate answer to that question starts with, okay, well, how many things do we support and where do we want to end up, right? And because we have, on top of, we have distinctions that are worth sort of placing today between APIs and implementations, some of which are starting to emerge in like pieces and bits and pieces in places. The two places where we're seeing, an implementation is something that is actually implementing query logic and doing it natively versus something, query logic is just like what we define to be the canonical behaviors that make query. And then an API is something that is asking something else to execute query logic for you and bring it back and give you back answers, usually involving some sort of intermediary, whether that's a command line or a network connection. Two places that are not listed on this chart that are worth bringing up is like we've had some situations where parts of very, 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 very small but light parts of query have needed to be implemented in JavaScript for the desktop project, which is the first thing that I'd like to bring up in very small ways. And none of these are like the actual like interaction with IPFS or creation or persisting of data, but like the way that we parse dataset references, for example, has ended up being implemented in JavaScript, and the way that we deal with and validate like dataset names and the way that we understand what is a canonical reference. Like there's a couple of bits and pieces that are starting to emerge as important parts of Query Desktop in JavaScript. Then on this, and then on the Python side, where the Query Python client, Dustin, you can speak to this, is written almost entirely as a wrapper, right? It's not doing anything special.
Yeah, it's basically just shelling out to the query command line app and then parsing the output.
Right. And so it's doing a lot of just like using Python's built-in capacity to run process calls, right?
Yep, exactly.
Yeah. And so just to set this conversation where we kind of want to kind of end is actually where Asmir's question, in my opinion, of like, in a hosted context, it's actually the hardest for us to deal with if we think about it, because we do not know whether or not we even have the capacity to install external binaries, right? Like so as it stands right now, the majority of the example that Dustin just cited, the baseline assumption is that we have query as a executable binary that is running all the business logic, and that's written in Go, and the Python client is calling to that. We also, that binary client has a bunch of these various APIs, which we've had to write over time. And so we have gotten to the point where we have many ways of interacting with that binary, with that executable. And I think it would behoove us to think carefully about the future of this and start driving our attention towards either a subset or deciding which ones we sort of want to eliminate, what we want to move forward with. Because there are numerous ways of approaching this big problem of like hosted cloud environments where you have access to very, very, very little, right? One example might be swapping out the binary assumption for an API assumption. And so you could write something, an HTTP API assumption, right? Where now you're using Query Cloud as your backing instance, and you're logging in with your Python client authenticates in one step. So in the demo you just gave, Chris, if we were running this in, say, Google Colab or a hosted notebook of some kind, and say on a kernel on Kaggle, you could say, okay, import the query library, and then I would just do like query.auth or approve. Currently we have a prove method, and that would somehow prove you with and connect your account to to Query Cloud, and then you would make requests over HTTP and get responses back, and now you don't need the binary anymore. And so that all puts a lot of pressure, presumably, on this HTTP JSON API. There's no reason it couldn't also talk over this new WebSocket thing. Okay, I'm going to pause there. That's a lot. Does anybody have any questions about what I've said so far surrounding the ways that some of the problems before us about APIs and where we're going? Anything yet? I'm going to leave lots of silence. I know you have thoughts. Okay, then I'll just finish going through this chart and then we can talk. So this chart that we started talking about, but like it's just worth sort of bringing up some historical context and bringing some history to this conversation. So this outlines everything that we can, all the ways that you can currently talk to the query binary, the query.io, the thing that gets compiled, it's written in Go. You can currently, if you start Query Connect, you can talk to it over HTTP. So you can submit HTTP requests and you're going to send JSON to it. Generally, you're going to get JSON back. There are some small exceptions. Sometimes you will get, for example, a zip archive. Other times you can ask it to spit out CSV data. But by default, the HTTP API assumes JSON as its serialization format. So that's the sort of common denominator format that the other end of the wire, the client, is going to need to know how to speak. The new one that has really emerged, that was started a while ago as a need from desktop, the original Query Desktop actually used polling, and so it was constantly using this HTTP API, and it was hitting it every 3 seconds locally, asking if anything had changed. And that was wildly inefficient. The problem with polling is you don't have duplex communication. And so WebSockets are a new API we introduced that allows duplex communication, which basically allows the core binary running to tell the other side of the WebSocket that something has happened or changed. Its primary conversation and serialization format is JSON as well. And so it mainly uses JSON for doing all of its talking. Long before that, we needed a way inside of the command line client to talk to other copies of queries. So this is actually the query command line talking arguably to itself. But we have a funny situation in Qri where, because we maintain a decentralized connection or a distributed web connection, we have one process that ends up holding a bunch of shared resources and important resources. And that's the thing that's actually connecting to peers on the Qri network and moving around data. And so in order to be able to still see what's going on, you need some way to talk to that binary when it's holding those important resources. And so we have this net RPC tab for doing those things. We think this is easily the worst of all of the decisions we've made in terms of APIs. And for the record, I made this decision, so I'm the one who bears responsibility for this magnanimous stupidity. But it serializes over the encoding GOB interface, which is another thing that is inside of Go as a specific format that most people don't use and really isn't worth investing in these days. And so we really want the Golang RPC protocol to go away. I think we've all generally agreed that this is something that we'd like to see removed as soon as reasonable. Some stuff that's gotten some more attention lately has been the next two, which is the CLI actually is itself an API, as we've been seeing used in the Python client, where you're just running commands like query list and getting the output of that and capturing the output of that and using it for something. And so that is an API, right? We saw that in spades this sprint, where we actually needed, on the Qri desktop manages a copy of the CLI to do all of its work. And it actually needed a way to know if a migration needs to be run. But that's not a piece of information that can be delivered over the HTTP API, because you actually can't turn on the API without running the migration. And so there's this lower level API of we needed to know, basically by running commands, whether or not a migration needed to be run. And so we had to make some adjustments to the way that even the CLI functions. It now returns exit status 2 if a migration needs to be run, versus exit status 1 if a generic error occurs, and exit status 0 if something else functioned. But we're also seeing in the CLI a number of ways in which it's kind of being used it's being used in a lot of different contexts for a lot of different forms. We have a number of commands inside of the CLI that, if you give it format JSON, it will spit out JSON formatted data. And that's an example of where you're actually really twisting the sort of usage or purpose of the CLI to sort of operate like this one-off HTTP API. It has some real advantages. When you're running HTTP, you need a process that is ready to serve and accept those requests. When you're just using the CLI in a one-off query, if I'm just typing query list and hitting enter, you're grabbing all those resources, listing out that data, and then releasing all those resources again. So it's a really, really efficient way of talking to query data. And that's what the Python client is doing in the background, which is, I think, quite nice. And so this is an API that we have to maintain. The problem here is more that we need to really be much more rigorous about this as an API. I think we have a lot of very differing support across a number of different subcommands and the way they operate and behave. And so I think I personally would like to propose that we get with the CLI into a position where it is much more easy to reason about how you can modify the output of those commands to be more consistent across all of the commands. As a sort of simple example, I'd love to be able to just add -- format JSON or -- output equals JSON to anything and always get JSON output. For me, that would be like a really, really nice characteristic to see across our command line tools, because people are actually using it this way. And by people, I mean official clients, like stuff that we're building. And then last but not least is the sort of lowest level API of them all, which is actually inside of Go itself. And this is the lib package. And it's worth mentioning this here because this is the origin of all the other APIs. The lib package is the sort of closest thing we have to canonical definition of everything query can do, and all of the arguments that it takes and what it gives back. If we change an API, it starts with a change to this lib package. And Query Cloud actually uses the lib package natively. We also have a number of other running experiments that import the lib package directly and run query in process and actually do stuff with it directly. And so if you're writing Go code, just importing the query library directly and interacting with query that way is the sort of final API on this list.
Brendan, I just had a thought. I think we might have a hidden API that's like underutilized right now, but the way that we talk to different peers over P2P, there's certain expectations, and this is like super not formalized yet. Also,
yeah, you're totally right.
Super using it, that we're not relying on it, which is why it's not like formalized and why we're not thinking about it super hard. But
yeah.
I think there is another layer there.
You're absolutely right. This is
Doesn't-
slight.
and it doesn't do everything that doesn't guarantee, doesn't have the same guarantees that some of the other ones do, but
yeah, and I think it actually should be outside of this box because exactly as you mentioned, it's okay. So, and we should close this loop. Its primary serialization format, for the most part, is JSON, but it does sometimes use CBOR, and it's actually subdivided into a number of sub APIs. The libp API is distinct in the fact that it uses its own sort of definition of APIs for different business logic. And so the actual syncing of blocks is an algorithm called desync. That's its own API, its own serialization format, and so on. And then the way that we move around log is its own thing. I think this is kind of separate because this is actually orchestration between peers, and what this discussion is entirely about is more geared towards a conversation about interacting with Qri as an individual end client, which I think is distinct. It's worth mentioning on this list, though, Casey. I think you're absolutely right that we have this other API. Cool. And then just to quickly run through this list, we now have 4 things that are going to consume this list, at least. Right, so we have Qri Desktop, which is a JavaScript project. We have Qri Python, which is now a Python project. We have Qri Cloud, which is a Go project. And I've added etc. here because there are a number of other experiments. Like I've got a data analysis tool in the works that is entirely written in Go that interacts with this in a funny way, and a few others that are sort of like just waiting in the wings, sitting around as other projects that interact. We have this like temp registry server that imports it and sort of interacts with lib in a direct way that is causing a whole bunch of problems for us right now. But yeah, so there's a number of situations here where we are interacting with this in different ways. And just to speak last but not least, in terms of documentation, the HTTP API is the closest thing to actually being documented. It has an open API file that is out of date, but at least it exists. Everything else is really largely undocumented. And I think that's an issue. One of the ways that we sort of get around documentation is we often talk about the idea of having like just the Go doc for the CLI and the lib. We can actually do godoc.org, github.com, and then we can go query-o query, and then we can say lib. And this is just to prove that we don't like never write documentation. We deserve a little bit more credit than that. But you can actually see some of these, the formal definition of the lowest level API of the lib itself is here. And so if we look at, for example, log methods, which is talking about the log command, and if we do log, we can see log returns a history of changes for a given data set. So we have some documentation, but the HTTP API is closest to having actual documentation that is real and sort of user-facing and something we can put on a website. Cool, that's the background. So let's talk about the future. And I think this is the bit that is actually worth discussing. And the reason I wanted to bring it up. We have a lot of APIs. I would like to either commit to some of them and document them, or talk about the one major shortcoming that I think is possibly going to show up that needs to be sort of surfaced here, which is basically the performance of JSON as a serialization format. Sending around hundreds and hundreds of megabytes of JSON is slow and doesn't work very well for Python as it stands. So I'd like to open the floor to discussions of different formats for serialization, APIs that we think should be added or removed, emphasis on removed, and what we think in terms of possible future uses that maybe we aren't accounting for. And as an example, Asmir, we didn't have, non-binary, sort of no binary available context where we have to use something like HTTP. So yeah, thoughts? Has anybody been thinking about this?
I agree on the slimming down part. The things that I would suggest, and I brought it up a couple times already, is switch out the RPC layer for something like protobuf or something like that, just to keep the performance aspect of it, but still have a fairly raw / binary protocol. And I'm definitely in favor of keeping one version of the HTTP API because that's kind of so universal that it's probably the easiest way to hack around without committing like to all the low-level stuff. And by that I mean probably use WebSocket, because we're more and more kind of like introducing that event-driven architecture or approach, but have a graceful fallback, maybe to just raw HTTP or something like that. Anyways, my 5 cents.
How do others feel about protocol buffers? I think that's a really important question. There's a couple of things worth noting. Query already has to import the protocol buffer thing into the Go binary because it's present in a number of libraries that we depend on. So it would not be an added dependency. Protocol buffers have some advantages and disadvantages, but I'd love to hear thoughts from others.
I know, I mean, from looking at a lot of the libp2p stuff, libp2p relies heavily on protobuffers. So like you said, it wouldn't be like a new thing that's happening in the query world.
So one, like, speaking just about protobuf, there's a couple of things that I really like about having it. And one, it literally formally requires you to define like most of like, well, not most, but all of the data structures and a lot of the interactions. So that's one way to document the API. And second is, I'm not a huge fan of using the CLI as a being just wrapped and that as an API. I mean, it works until a certain point, but if you want to get advanced functionality later on, like, I don't know, split files and stuff like that, especially for large data sets, that's going to become harder. But for now, even piping from like CLI is okay. But I would like to keep one like lower level API and then a high level API like HTTP.
So if you had to choose, Esmir, you would not prioritize like a tip to tail port and polish of the CLI, instead focus on protocol buffers over an HTTP API.
Yeah, I think that's a good way to present it. I'd say CLI can live kind of in its own world. I mean, we have the Python client currently depending on it, even though it might not be totally ideal, but it's good enough for now. I'd say protobuf might be good as like the lowest level definition, like that will define all the APIs, and then we build on top of that for the other ones.
But something that I think is kind of interesting in this is we've jumped through a lot of hoops to make the API of lib specific because of RPC. And I'm wondering if there's a way to combine protobuf with the lib layer so that there's a more clear handshake, I guess you could say, or contract between everything that's using lib that can be more clear and more explicit because we don't have to tie ourselves into knots to fit into RPC.
To even expand upon that, with what Casey was saying, the thing I was thinking before was like, it'd be neat if there was a way to kind of combine different APIs. Like, I don't know if switching to protobuf alone would solve things because it's just swapping one serialization format for another. I think like if we could combine things, like if we had some way to take the lib contracts, maybe specified as protobuf, and then like generate an HTTP API off of it that is also used for P2P and for RPC, like that would solve a bunch of stuff. Because right now, a big problem is that we have duplication. The HTTP API is duplicating code that's already talked about at lib. And like if we could automate that, like generate code even, or maybe something less crazy than that, that would be really cool. And it would mean that lib then becomes the defining contract that everything is talking through.
Frosty.
You're talking about going straight protobufs and building an API on top of it, not using something like gRPC.
No, I'm not saying, actually, I think gRPC would definitely be part of the conversation regardless.
Okay, because I mean, I haven't worked with any of these, but gRPC gives you a JSON alternative to any API by default.
Absolutely.
And you're going to need the JSON API still for certain things.
That's a really good point. It's a very good point. And I think these are actually really I love the idea of just generating the API code because we could generate the documentation as well if we wrote a good generator, which would be really nice. And then that would mean that one of the biggest problems we have is drift, right? Where we make a change in one place and then it doesn't actually get effectualized in another place. And so if we could, by reducing the number of places we define things, I think that's actually the project here. It's less about the APIs. It's more about reducing points of definition to one. I don't need to give examples of why that's a good idea, but I have been living them in real time this week. Yeah, that's okay. So let's talk about protocol buffers, because there's another. We've been using flat buffers a bunch instead, and I think it's worth talking about the conversation about what's the difference between a flat buffer and a protocol buffer, and some of the frustrations with flat buffer that we've experienced, because we've actually played with it and we have a lot more firsthand experience with it. So a flat buffer is also a project from Google. It solves a lot of problems similar to protocol buffers. It has a couple of unique traits that are distinct from protocol buffers. But the ways that it's the same, you still have a flat buffer file where you define the actual schema of the data, and then you use a code generator to generate code in whatever language you need that actually sort of interacts with the flat buffer itself. Flat buffers are originally intended, they were sort of started from the world of like writing video games and doing like very low latency connections for over a network to send something that is in a nice format that has the lowest deserialization overhead cost possible. And so flat buffer's claim is that you don't have the serialization overhead. It's almost non-existent. It's a bit of a semantic thing. Like, you're still turning something into a stream of bytes, and then you have, on the other side, you have a stream of bytes to look at that you have to get. But where you do have kind of a zero cost deserialization is you don't actually need to deserialize the entire flat buffer to read it, which is a very, very interesting characteristic when you're sending a 200 megabyte data set. The idea that you could send a lot of that data or part of that data, actually you do have to send the entire buffer. So you can't just like stream part of it and then start reading. But if you send all of the data over, you don't need to deserialize the whole thing to read from it, which is an interesting characteristic. I don't think that it's like this major show-stopping thing, but it does speak to, it is a distinction. The other sort of like vote in the column of flat buffers, it is the underlying format used by the Apache Arrow project. And if I have not been able to get a clear answer on this, I just need to do more research, but I believe Parquet files actually rely on something very similar to this. And Apache Parquet files are used in a number of places, including like Google BigQuery and a bunch of other places. Flat buffers themselves actually use data interning, so values that are the same are stored in the same sort of footprint of the buffer, and then they use offsets to distinguish where data is located. And so you get a nice compression factor if your data has a high amount of duplication, which is very real for us, where we're talking about data sets where we have a lot of cells that are the exact same value repeated numerous times. The idea that duplication becomes a compression win for us is a really huge sort of step forward, and a reason why flat buffers are worth sort of talking about even in this conversation. Downsides, I'm going to leave some space for Dustin to grumble on this one, because Dustin has done the most low-level interaction with flat buffers, I think. Maybe with me as a close second, but the problem is they're not super developer friendly to work with. They don't generate APIs out of the box. You're not getting a free JSON API out of flat buffers. You're not getting nearly the same size of community that is behind protocol buffers. So you're not seeing as many. So as a direct consequence of that, the Golang implementation of flat buffers is like quite lacking in contrast to some of the other language implementations. Those are my gripes. Dustin, do you have other gripes?
The main one is that and also my internet's a little laggy right now, so apologies if I cut out. The main issue I've run into with flat buffers is that they're pretty biased in how they want you to work with them. So they have this advantage where it's really quick to read all the bytes, into memory. You don't have to parse it, and you can access individual fields. But if you want to do something like, you know, modifying something in the middle of a structure, you have to like copy the whole thing. And like, you have to know like what strings are going to be inside your flat buffer before you add them. So you have to like pre-allocate things, and then it makes really awkward code that you have to write. So they become like kind of tough to work with. If all you're doing is like loading something up and then looking at like one value in the structure and then like throwing it away, like it's really efficient at that. But that's not usually what we're doing in all cases, especially like all cases. It also, yeah, I don't know. That's kind of my primary thing that I've run into with them.
Anybody else played with any of the flat buffer code? Asmer?
I did have some experience with gRPC and protobuf, but just wanted to add one more thing in both for the gRPC side. You can pass context in those, and I think that's really cool and really helpful. And we're going to need more of that anyway, so not sure whether we can do that with flat buffers. I imagine we have to still build on top of it.
Yeah, and I think you could actually expand what you just said. Flat buffers actually don't give you a way to move this stuff around. They are purely a serialization format. So they're just like, hey, you had some data, and now it's a flat buffer, and it's a bunch of bytes. And it's like, what do you want to do with those bytes? Do you want to like stream them somewhere? Do you want to put them on a disk? Like,
actually, to add to that, something I just remembered. In order to make them more convenient to work with, there's a lot of cases where, you know, you read in the flat buffer and then copy it to another structure to have something that's like very convenient. Mm-hmm. And once you do that, you've lost the fact that it's no deserialization because you just added that step yourself.
Yeah.
So yeah, if it's kind of like if you're using them for the one specific thing they're good at, then they're a huge win. But aside from that, it isn't super compelling.
Mm-hmm. I think that makes a lot of sense. And I think that part sort of speaks to the way that we've been using flat buffers. We use them for internal storage, right? Like we use them a lot for, cool, I want a good serialization format that is fast. Like Qri list as an example is built on top of a thing that is written on top of flat buffers. And list needs to open, get its stuff into a format that you can work with really quickly, give the results, and then ideally save that to as small a thing as possible. Logbook is another thing that's written in flat buffers. And logbook is, again, intended to be as small as humanly possible. Its real contention is that eventually we're going to have tens of thousands of commits and many, 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 many messages. And so we need to be able to fit, and we have to send those, the entirety of them, around a whole bunch because they're append-only logs. And so we have to take 10,000, 15,000 messages, cram them into one blob of bytes, jam that over the wire to somebody, and that's where the synchronization conversation starts. And that's sort of the primitive that we're built on right now. And so for those things, I think flat buffers work really well. As Dustin has said, manipulation, not really that great. We're also, for us, we're not widely in both of the versions that I mentioned. You're either just reading something from disk, deserializing and spitting something out and then going back to disk, or you are talking over a P2P protocol, which is definitely not implemented in gRPC. And so we don't have the simple, the libp2p universe is definitely a different animal. But yeah, and so I think that's like, those are the two biggies that jump forward, are the protocol buffer and flat buffer conversation in terms of formats for working on stuff. I'd like to sort of quickly turn the conversation with sort of the remaining 10 minutes to the WebSockets versus HTTP stuff, which I think is, Esmer, you alluded to a little bit, but I think is worth talking about just in brief here. We've been using WebSockets a whole bunch more, or at least intending to use them a lot more, now that our event system is much more sort of, we have a foothold in events where we think that it will work well. To talk briefly about this sort of evolution at the lower levels of the stack, we are turning Qri into sort of a collection of subsystems, and that's been a project that's been happening for a long time. So the idea that something like Logbook or DS Cache are these sort of like purpose-built things that do specific stuff and do their one job very well and are not really loosely coupled or not tightly coupled to each other. So Logbook is handling, hey, what did you do when, so that I can synchronize with other people. DS cache is handling what do I have locally, and like what is my list of data sets, what is my list of most recent data sets. It's a cache. And so that should, again, not really care about what's in your logbook. It should just be able to be its own independent thing. And so for that, we have this event system working really well. The nice byproduct of the event system that we now have up and running for communication between those subsystems is that we can just punch over all those its same events of like, hey, a data set was just created, or hey, a node just went offline, or hey, we just connected to a new peer. All of that can now be really easily sent over a WebSocket, which is thankfully a bidirectional communication layer. So things like Qri Desktop can now sort of see, oh, you asked me to save this data set. It's a 2 GB file of data. And I now can start sending you progress events over the WebSocket of, hey, save progress made, save progress made, save progress made. And that can just be this sort of thing that starts happening as a consequence of an action that desktop kicked off, but it's nice and loosely coupled. So WebSockets are really jumping up in terms of as an API. My question is, what is the seam between a WebSocket and HTTP? And to what extent do we want to use WebSockets for what might be the gRPC layer of this, where for CLI to CLI communication, where basically when we have a node running and we need to do, when a command line client needs to be like, hey, I'm fetching this thing from the registry, the same way that desktop is doing interactive communication with the node via a WebSocket, should 2 command line client instances be using a WebSocket for that same conversation? Yeah. Caveat, downside that should be mentioned, WebSockets aren't great for really long messages. So like dataset bodies, not as great over a WebSocket, because you end up in a situation where you're sending 2 megabytes over a duplex communication channel, and you now have to use something called frames, which sort of breaks apart messages and can cause corruption really easily. I've had problems myself writing good, clean WebSocket code that exceeds the sort of like 2 kilobyte frame size that we're using internally. And so for that, I think it's better to switch to HTTP API stuff. But I want to understand like how folks feel about the interplay between WebSockets and protocol buffers and gRPC, and what thoughts you have on that, if any. It's a lot. Maybe I'm just spilling stuff into the air, but Rusty.
Outside of stuff that only speaks WebSocket, you know, Electron, well, not necessarily Electron, but, you know, and the website, or Qri Cloud rather. If you're going to gRPC, why wouldn't you try to standardize on that everywhere instead of using, you know, you can't use WebSockets everywhere, so why don't you take everything that can't use WebSockets and standardize on whatever your highest level, you know, your strongest protocol is?
I'd agree with Rusty on this one, and I'd say personally, WebSockets feel more like they should be used to kind of like subscribe to those events, but they shouldn't be really doing like proper actions. Maybe like those are just like updates that you send back and forth, while everything that's like meaty should go over proper APIs. So like, I don't know, list, add, push, pull, all those fancy things, they go over gRPC, let's say, in this case, and then you can get all those fancy like progress bars, updates, I don't know, completion notices, notifications, all that fun stuff can go over WebSockets just to kind of like maintain a bidirectional communication channel.
So we're basically saying WebSockets are a subscription-only style. We would not push, hey, go save this data set over WebSockets. That would happen over HTTP.
Exactly. So those commands would be like explicit via the like low-level API, whichever we choose for that, and we would just communicate like in between data over WebSocket.
Dustin, your thought?
I mean, save should use a WebSocket in that there are notifications coming back about the saved progress. But I'm not convinced that they're good to like be the replacement for everything else, I guess. then again, if we do find a way to like do what I was suggesting before, like have a way that everything is like built off of lib and kind of automatically inferred or whatever as an API, like WebSocket can just be there like as another way to call lib methods. I don't know how doable that is, but yeah, could be interesting.
On the save example, or a couple more come to mind, like transforms, SQL queries, those will all be like longer running things that could take time and need progress. I'd be happy like if we kick it off and just have it run directly from the API, and we just communicate back the progress so we know what's happening, or like metadata about the process while it's happening. For example, SQL queries, they will have a like build-up step where they figure out like what's being fetched, joined, and stuff like that. That can all be communicated back, and that's functional data that you can then assemble and use on the desktop side. But it's not really like super actionable data. It's just result data that you can then you need to display it somehow. But like moving data between like, I don't know, desktop, the end result and stuff like that, that should be just the result of the API call.
Gotcha. I like it a lot. This is basically, we just made API, the WebSocket just a receive only, and kept it as a receive only subscription to, it's basically a breakout box that lets you subscribe to events. I can think of nothing that requires going the other way, which is good. So if we kept this, Rusty.
Just seeing if Asmir is saying kick off an operation through a different API call, and you're returning the results and the progress through WebSocket. Is that what you were saying?
Not the results. So
well, no, I mean the result of the operation, not the result of the call. But you know, you're kicking off the progress, or are you sending the progress back through WebSocket? Yeah.
For a full example, select all from World Bank population and join it against, I don't know, NYC turnstile data on whatever thing. And now it's like crunching in the behind the scenes and figuring out there's like 10 terabytes of data on the World Bank population, and it's calculating the columns that you're fetching, and then we're returning, hey, you're gonna fetch 5 megs on this and 10 on that, and it's gonna take 5 seconds estimated, all while it's crunching in the background. And that's all over WebSocket. And then when the final result of the query is done, it just pushes back as the result of the API call itself. Seems like long polling maybe a little bit. I don't know. We have to figure it out.
Yeah, I think that's to add a little bit of context or color to that example, Asmir, because you just mentioned one place where you might actually theoretically want a WebSocket pushback, but I think it would make actual sense to just do this in the HTTP response code, where you say, hey, I'm about to run a query that is going to download a gig of data, right? And it's like, and what we've talked about in design documents is we want to actually interrupt the user and say, you're about to download a gigabyte of data. Do you want to do that? In my mind, it might be smarter if, okay, you send that request over, query does some figuring, hits some threshold, and then responds with like HTTP, I don't know, some response code that is like error or bad request, but is basically gives you a message, an error message back that isn't really an error per se, but is an interruption that says you need to rerun this with a parameter that says, and yes, I do confirm that I want to download a gig of data, which would give you that call and response of like, do you want to do this? This might not be a great idea. And we can, instead of another version of that would be progress comes in over the WebSocket, and then the actual process does not finish until you send a message over the WebSocket saying, hey, blah, blah, blah. But
yeah, so
I think it's much better to do the former context of just responding and saying, okay, you need to try and rerun this with.
Yeah. One more idea on how that can play out is, and that ties in nicely into the context thingy. Once you kick off a call, you get a request ID, which you can then hang on or subscribe to. And then along the process, you can respond to that subscription or send out an event to that specific request ID saying, hey, it's currently halted. You can, and then the client can do whatever it needs to do to continue it or stop it or whatever. So on inflection point, and then it's still like a one-way kind of like notify existed. So
Yeah.
you just get an update like we interrupted. You now have to decide what to do with it.
Do you think that would not be better handled with a very long-running HTTP request?
So my only like scare on that point is like what happens with super long-running like requests. Like it's one thing to have it run half an hour, and it's a completely other beast if you have it run 2 days. I mean, I don't really have a use case right now, but I can imagine like a year from now we'll have diffing mega like data sets, and that will take like 2 days, and it's going to run on cloud, and then you need to like just sit and wait till it finishes. So it might make sense to just give you a token which you can like identify your own request and then just follow along. I know like those vision APIs and things that convert video or the cloud providers, they generally tend to do it that approach for those super long running ones.
Yeah, and you have an endpoint you can get with like it's like status, and then it gives you back the request IDs that are currently in process.
Yeah, and essentially WebSocket would be like the live version of it, and then you can do without WebSocket and just ping as much as you want to get the current result.
Lovely, I love it. Okay, it's 3 o'clock. That really flew by. I don't think we've really arrived at any answers here, but I think we've ruled out some things. I think we don't want to use flat buffers generally as a thing that we want to see proliferate all over the place until we see a better reason for it. I think we don't want to see push over WebSockets. Very interesting. I totally agree. I think we see WebSockets as this event subscription only JSON serialization format, light, small, keep the definition of the API really tiny. HTTP API is clearly the thing that we need to invest more time in documenting, in understanding better. JSON is a default serialization format I don't think can ever go away. I think you need to always be able to sort of default to JSON. So if we get that right, cool. But I also heard a bit more articulation of a de-emphasis of this CLI as this like pseudo API. And I think that's really interesting. I think we should sort of talk about that a little more and see if we can't make sure we sort of recommend folks to the right direction for that. But to finally and formally answer your question, Asmir, I think we sort of alluded to this at the beginning, but like in a situation where we're in something like Google Colab or a hosted notebook where we don't have direct access, I think things like the Qri Python client need to transition to a situation where they're able to interact over HTTP, and that's going to need to be a really sort of near future scenario, and we're going to need some sort of authentication mechanism where the fallback API to not having a local version is to just use the hosted query service on query.cloud, which we would make available. And we already currently use this pattern for Qri Desktop, right? All of Qri's browse experience, Qri Desktop's browse experience uses Qri Cloud's registry API to actually get data and show you what data sets are available. And so there's no reason not to just formalize and extend that pattern. Obviously, the big caveat is we need at bare minimum rate limits, and if not, a billing scheme for Qri Cloud usage. Cool. Thank you so much for your time, everybody. Thank you, DK, for joining. It's nice to see you here, and hopefully this wasn't the most boring conversation you've ever listened to.
Well, I mean, first of all, I apologize for being a little bit late. I probably missed a better time for an intro. Yeah, well, I mean, a lot of this has a lot of context I'm not familiar with, so I'm trying to kind of slowly absorb by osmosis what's going on.
Which I think is the way that most of us learn around here. Well, you can do a better job of introducing, but I think I've seen you in our Discord channels. Is that correct?
Yeah, I popped in one time. I haven't had a lot of time to play with Qri since then, but I'm hoping to do that a little bit later today. And I'm starting my day a little late, so maybe it'll be after hours at this point.
But no worries at all. Hey, thank you for joining. Please, our next call is next Monday. That'll be the Using Qri call. It is at the same time. Oh,
a week from this coming Monday.
Right. Yeah. Sorry.
Bi-weekly.
In 9 days, right? Is that right? 10 days? But yeah, that time. It's still at 2 p.m. Central Eastern time. But the call is there if you want to join us again. And if you join if you join off the top, we can definitely make a point of like introing and answering and giving it space for real questions if you'd like to ask them in person. But we're also always just available on Discord and happy to answer anything that's going on there.
Cool. Thank you.
Awesome. Thank you so much, everybody. It's really appreciated. Have a lovely Friday. And we will talk to all of you same bad time, same bad channel in 9 days.
See you, friends.
Sounds good.